Hi there, this is take 3. This is a complicated video to make. This is a video about a Ferrograph RTS2 recorder test set, and this is the professional version, in that it doesn't have the little silver labels of the older test sets, and also it's got a nice white top here, ivory colour top. This has been fully overhauled and set up and tested, and it's going to be on eBay pretty soon. Just thought I'd show you quickly the functions, because there's not really a lot about this on YouTube, and it's quite difficult to get your head around really if you don't know how to use this. But you can use this for any make of tape recorder. It doesn't have to be Ferrograph, obviously, and you've got different things you can do with this test set. Obviously you have things like wow flutter meter, so you can see how the motor is wow and fluttering. You have distortion measurements here as well. This comes with a very nice frequency generator, and you can set the output of the generator, voltage output, and you have a fine adjust as well here. And this scale here goes from 15 to 150. So at times 1 here, that's 15 Hertz to 150 Hertz. Times 10 obviously is 150 Hertz to 1.5 kilohertz, etc, etc. So basically the way that you would use this, if you see here, you have an output here marked oscillator, and this is the output of the test set. So at the moment I have depressed the wow and flutter drift mode, so I'm checking for wow and flutter. So this test set should be putting out just a bit above 3000 kilohertz, because that's the frequency that usually wow and flutter is tested by. So it's putting out of that jack there 3000 kilohertz, and there it is on my little cheapo Chinese oscilloscope. I'm using this one because it's smaller for the workbench. I've got a nice Hewlett Packard, but this one shows it okay, and you can see there 3.13 kilohertz there, and there's the wave. Obviously that's moving about a bit. I could stop it, but you get the idea. It's the sine wave is putting out. Now, because I haven't got room on my bench for reel-to-reel, what I've done is I've cheated. So this here, this is where you would plug the output of the reel-to-reel into, the one that says meter here. And what I've done is I've got a signal generator here, and it is generating a signal which is identical to what this is putting out. Okay, so what you normally do is put the reel-to-reel in record mode. You would record this signal going out onto the tape, monitor the tape, put the tape in monitor position, and then the output of the tape recorder you would plug into here, and that would tell you the frequency coming out, whether it equals the frequency going in. So here you can see, because I've set these up the same on this lower scale here, that's drift in percentage, you have no drift. But if I were to vary the signal generator, imagine it's wow and flutter, you'd have something like that, varying the level up and down. So that is what you would see as wow and flutter. Obviously it can get really bad. It would be quicker than that actually. Let's just see if I can move along here. Right, it'd be something like that if you had a real problem with your reel-to-reel. If it was normal, you'd probably go between the -1 and +1 % of drift. Be like that. Probably normally you would get a little bit of drift. It wouldn't be bang on unless you have rock solid motors, which you might have. But yeah, this will tell you if there's any problem with the wound flutter. Also, if you have something like that, then you might have a problem with the speed. So this can be used in various ways, and this meter can be used as a monitor as well. So that's wound flutter. Obviously you have different settings here as well. You wound flutter within 1%, 0.3, 0.1. It's all calibratable, as is this whole test set calibratable. If I set this to input here and calibrate, sorry, oscillator, input 1 volts. I'm just going to have to think about this a minute. Here we go, input, there we go. The LF cut was on. If I set this to input here and calibrate, this needle here will go onto the calibration mark here. See, you see that it says cal, and you can set it up in the 1 volt range here with this little trim pot there. So this is perfectly set up, absolutely set up. I've done everything I need to do on this. This has got a very nice little oscillator as well. So if I take the calibration off, put it to oscillator read. Now here at the moment we have it set to 100 and times 10, so that's 1000 kilohertz. There we are, 1000 kilohertz. Obviously if I increase this up to 150, that would be 1.5 kilohertz, and here we have it, as near as anything. So yeah, I'll just turn this up. There we are. You can see the difference here, and you can obviously use these as various test signals. You can even make a test tape up with various frequencies to test certain things, and you've got a very, very wide range of frequencies here, and voltages as well. You can alter the output voltage here. It goes up to 3 volts here, and obviously you can see that on the actual meter here. And at 3 volts, let's see, at 3 volts it can be calibrated as well with the coarse and the fine controls here. It's pretty there we go, oscillator out, here we are. So I'm calibrating this to 3 volts, see, and this is on the 3 volt range, and it also says 3 volts on the monitor here, the oscillator output 3 volts. I'll turn the frequency up a bit so it looks a bit better. 3 volts. If I want to increase that 3 volts output, I can with this fine range here, and it will go all the way up to 9 volts. So this can be fully adjusted. Now these meters can be quite complicated, and it took me just a little while to get my head around the distortion aspect of this. This can actually read distortion, and that is very important on anything audio. So how you actually read distortion is you have to press this distortion 100%, and what you need to do is make sure this fine control's in the middle here. Actually this needs to be on the 1 scale. What you do is you use this knob here to make sure the scale reads exactly 10. Okay, I'm going to turn the frequency down here. Apparently distortion works within a certain range of frequencies. It's up to about 110 kilohertz. So I'm going to set this to 1K, well 1.031K is what it is. So this can measure it. Basically, I want to set it to read now. And then what I need to do, this is a complicated bit. See here, distortion, meter, balance. I have to turn these two down to reduce the reading on this to a bare minimum. See, it's going up again now, so just reduce it down to a bare minimum. Also the phase, it's a bare minimum. Okay, so now when it's set to read, I'm actually reading the distortion that's coming into it from this signal generator. Normally you would have a cassette deck or reel-to-reel or whatever you want to read the distortion with, and with a combination of this switch here, which sets the millivolt meter, this is on the 100% range, so that's 100% if you remember. So you can see that it's pretty near the zero there. You can hardly see anything. There is a very, very slight movement there from zero, but you can hardly see it. So what you would do is you adjust this so you can see it better. This is on the 30 volt scale, which is here, and you can measure here. It's you can measure, that's 1% distortion there, so it's less than 1%. You wouldn't expect it to be much from a signal generator like that. So if I turn it down to here, 10%, so you can see 10% is there, sorry, it's there. So you can read the distortion in that way anyway. I'm not an expert on this, but I know that this is fully working anyway. But while I've got the top open, I'll just show you the quality inside is amazing, like all Ferrograph stuff. There's no integrated circuits in there, it's transistors and capacitors, so it's all fairly easy to fault find. And all these cards, they're actually inserted in card slots, so you can just pull them out and work on them if needs be, but these are so reliable, really. I've checked all the capacitors in here and everything, and it's fine. The pots are pretty good. They're sealed pots, very good quality sealed pots, so I can't spray anything into them to clean them. This meter is new. When I bought this originally, the meter wasn't working, as so many aren't. So this is a new meter. The scale isn't new, the scale is old, but it's pretty good. You can see everything fairly clearly, and obviously the light's working. So yeah, and I've got the cover here, top cover that screws on, that's there, and there is a brace here which goes along here to hold the cards in. So it's all in pretty good condition, and this is going to be listed on eBay pretty shortly. Thanks for watching. I hope this helps someone who has got an RTS2 and doesn't know what to do with it. Thanks a lot.